Before we dive into the assertion, it is persuasive to sort out what molecule gas pedals are. The Large Hadron Collider, LHC, worked by CERN, is a 17-meter ring of superconducting magnets. Similarly, it is the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the exact states of the first moment on the planet. But could this machine, intended to open the mystery of the universe, hold the key to something clearly different? For Boeing, CERN, spread out in 1954, is one of the world's most popular research associations, with 23 member states and endless researchers. It's a place for collaboration and innovation. The LHC is CERN's central project, yet it's only one part of a giant organization of gas pedals and tests. Imagine a course not so much for vehicles or but for subatomic particles in a trial of aptitude, persistence, and space itself. The LHC speeds up protons to almost the speed of light, sending them on a collision course that reflects the energy of the universe right after the Big Bang. The impacts create temperatures typically much hotter than the center of the sun. A massive number of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 locations around the gas pedal ring, connecting with the spots of 4 particle detectors: MAP, CMS, ALICE, and LHCb. Each fills a specific purpose, investigating different parts of particle physics. Together, they act as massive cameras, capturing images of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also called the God particle, and other anomalies that could reveal clues about the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. However, with each answer comes another question, and with each discovery, another challenge emerges. The LHC is not just a scientific instrument. It's an exhibit of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. However, as we push the boundaries of what we know, we must also consider the more profound and existential questions that arise. What are the dangers of probing the unknown? Could our quest for knowledge inadvertently unleash powers we have no control over? In the sacred halls of CERN, where the limits of human understanding are constantly pushed, a revelation has arisen that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a voice of expertise in the field of particle physics, has recently said something that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this goal, highlighting the LHC's remarkable potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very essence of the universe. It's an enticing possibility, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a very real phenomenon inside the LHC. The temperatures, the pressures, the raw energy, everything recreates the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. Yet, with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong back in 1978. The Russian physicist Anat Borsky encountered a disaster that would forever change the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in PCOO, Russia, a failure caused his head to inadvertently enter the direct path of a proton beam. The beam, with a force that defies belief, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was extraordinary. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone. Yet, he remained conscious and even walked to the center for treatment. The outcome was both disturbing and remarkable. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Surprisingly, Borsky's cognitive abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy. It serves as a reminder of the immense power and potential risks of particle accelerators. The dangers of a particle smasher like the LHC are not to be underestimated. The potential for catastrophic reactions, the very fabric of existence being altered, these are not the stuff of science fiction but real concerns voiced by respected scientists. One of the most unsettling and fascinating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are massive vacuum cleaners, devourers of stars, mysterious entities lurking in the shadows of our universe. The fact that the LHC could create such a phenomenon, even on a small scale, is staggering to both the public and scientists alike. Could this black hole eventually grow out of control, swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the object is heavy enough, it could create a well so deep that anything nearby would be drawn into it. This is an analogy for what could happen at the LHC in the realm of quantum physics, where the laws of the universe are both strange and wondrous. There is a hypothesis that additional dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This strange dance of particles has even caught the attention of some highly respected scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event known as a vacuum decay, an event that wouldn't just destroy the Earth but could potentially destroy the entire universe. The respected English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future possibilities for mankind, he explored the potential dangers of particle smasher tests, including those at CERN. His words weren't just cautious, they were filled with a sense of existential dread. He examined a worst-case scenario where a failed experiment could trigger a phase transition that would reverberate through the fabric of spacetime, resulting in a catastrophe that could engulf the entire universe. Rees' concerns weren't limited to theoretical musings. He assigned a low probability to these catastrophic outcomes. Still, he argued that even a small chance warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The scientists at CERN have run simulations, analyzed the theories, and taken every precaution to ensure the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of these measures, recognizing the inevitable concerns and questions surrounding the LHC's activities. He emphasized that there are rigorous safety protocols in place, thorough reviews, and procedures to ensure the LHC's operations are carried out with the highest degree of attention to detail. Cox reassured the public that the energies involved are well within what the Earth naturally experiences, and that the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and unstable that it would dissipate rapidly in an explosion of energy, a phenomenon predicted by Stephen Hawking called Hawking radiation. It would be a fleeting moment of cosmic wonder, just a brief glimpse into the void and then gone. Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or dimension. While this notion is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of intrigue, fear, and even myth. What lies beyond our universe? Could we accidentally release forces or entities that we don't understand? The concept of opening a door to hell has even been sensationalized in various media. fanning the flames of uncertainty. But how did this idea come about, and what does it mean in terms of scientific exploration? The concept of additional dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they could, in theory, be accessed or revealed under extreme conditions. Now, imagine the LHC as a giant key, opening doors that have been locked since the beginning of recorded history. When protons collide at energies never before achieved on Earth, they could, in principle, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC might indeed uncover them. However, before we get carried away with wild speculation, it's important to understand that while the LHC is certainly powerful, there is no definitive proof to suggest it will open a door to another universe, let alone to hell itself. Nonetheless, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of global catastrophe. But the truth is that the scientists at CERN are extremely mindful of the risks involved. They have taken every precaution to ensure their experiments are safe, and they continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly remarkable. It's not just a display of human ingenuity, but a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Yet, despite rigorous safety measures and detailed simulations, the LHC still evokes a sense of mystery and fear in some. The sheer scale of the machine and the energy it generates are awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident about the safety of LHC experiments, there are undeniable uncertainties. What if new, unexpected anomalies arise that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As particle collisions replicate conditions hidden since the Big Bang, the significance of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Regardless, the LHC's accomplishments in particle physics have been momentous. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Nonetheless, the quest for knowledge remains one of mankind's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into areas of physics where intuition no longer applies. For decades, physicists have sought to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a vital role in the formation of matter.